People crazy because they're not rational. And your I can statement is to make some sense of these numbers, to approximate these numbers to a hundredth. And we're going to talk really quick about what irrational numbers are, just a kind of a quick review, and then we're going to go into how to approximate them. Real quick though, this word approximate, that means to get close to the value of. You're not going to find the exact right answer or the exact answer, but you're going to find something pretty darn close. Okay, remember that an irrational number cannot be written as a fraction and is therefore neither a repeating decimal or a terminating decimal. Remember, any repeating or terminating decimal can be written as a fraction. So if an irrational number cannot be written as a fraction, then it can't be repeating or terminating. These decimals just go on forever with no pattern, no repetition, but they never end. They're not terminating in nature. And so here's a quick example of a rational number. 1/3, it's obviously written as a fraction, therefore we know it's rational, and it so happens to be a repeating decimal of 0 3/10 repeating. And so it is rational. However, the square root of 19 down here, remember that asks the question, what times itself equals 19? And it turns out that the answer cannot be written as a fraction, a repeating or terminating decimal, and is therefore considered irrational. We're going to talk about that right now, why the square root of 19 is irrational. Let's first, to go over a problem like this, I like to first consider, let me get these directions out where you can see them, all right? I like to first consider what perfect squares is this between. In other words, we know how to do the square root of 16. We know that's plus or minus 4. We know we can do the square root of 25. That's plus or minus 5 because 5 times 5 is 25 and negative times 5. I'm sorry, and negative times, I'm going to try that again. A negative 5 times a negative 5 is 25. Okay, so if the square root of 19 is going to fall between this number and this number, we can extrapolate that it's going to be between 4 and 5. So it's going to be some decimal between 4 and 5. Now I know from experience that decimal is never going to end. So we're going to try and estimate this or approximate it. What I'd like you to do is first try to pin it down within a tenth. In other words, we're going to do some guessing and checking to see what gets us close. Notice my strategy here. I know 19 is only 3 away from 16. Okay, that's the difference between 19 and 16. But it's 6 away from 25. Because of that, I'm going to come up with a guess that's closer to the square root of 16 than is closer to the square root of 25. Because the square root of 19 is closer to the square root of 16. So instead of trying 4.9 or 4.8, I'm going to attempt to try 4.3. Let's see what happens. I'm going to go to the next page to do the work here. So remember, I'm trying to figure out the square root of 19. I'm going to experiment here. What's 4.3 squared? And let's see if it's close to 19. So I'm going to have to come over here and I'm going to have to do some calculation. On these calculations, guys, just bang them out. Don't fret. Don't go, oh, it's a calculation, I don't want to do it, and get lazy. Just do it. It's not hard. Okay, cool. So this is 18 and 49 hundredths. That's slightly less than 19. We're getting close. I'm going to try 4.4 now and see if that's slightly more than 19. It should be, but I'm going to double check. Let's see what 4.4 squared is. Got to do the multiplication. Okay, 16, 17, 16, 17 here. Do that really quick. Okay, 19.36. Okay, cool. So now I pinpointed this down to within a tenth. I know now because of this that the square root of 19 is going to be less than 4.4 because 4.4 squared is 19.36, but it's going to be greater than 4.3 because 4.3 squared is less than 19. I'm going to recap that. 4.4 squared is more than this, therefore the square root of 19 must be greater, or I'm sorry, less than 4.4. And I know the square root of 19 must be greater than 4.3 because 4.3 squared isn't quite 19. Now, with that logic, the next part's super easy. I pinpointed it down to within a tenth, and now I'm going to split the difference. In other words, I'm going to approximate, my final answer is going to look like this. The square root of 19 approximately, that's what this squiggly equal sign means, approximately equals 4.35. And here's why. If I know it's right between 4.3 and 4.4, I'm going to split the difference with 4.35. I'm just going to go right in the middle between those two numbers. I'm not going to try and approximate it any more accurately than that. Oops, sorry about the announcement. That happens periodically. So you can look at it like this. This is 4 3/10, but it's also 4 30/100. This is 4 35/100. This is 4 4/10, but it's also 4 40/100. So it makes sense to think that 4.35 is between 30 and 40, or this 35 is between 30 and 40. So anyways, that's how we do it. Quick recap. Instead of doing another example, I'm just going to rehash this one super fast for you. Okay, we are trying to find the square root of a number that doesn't have a perfect square root. We find the closest perfect square roots we can around it. In this case, it was between 16 and 25. Then we figure out which one's it closer to. Well, in this case, it was closer to the square root of 16. Therefore, I know I'm going to start guessing pretty close to 4. So my first guess was 4.3. I may have guessed 4.2 first and realized you need to go higher. That's normal. That's fine. So I figured out what 4.3 squared was. Then I figured out what 4.4 squared was. And because 19 fell between these two numbers here that I'm hovering my pen around, then I knew that it had to be between 4.3 and 4.4. So I just split the difference of 4.35. On your answers for these guys, every single answer should end with 5 in the 100th place. So you should be accurate up to this point, up to the 10th place. And then the 5 is just telling me that this is between 4.3 and 4.4, somewhere between that. That's as accurate as we need to be. That's good enough. Anyways, I hope this video was helpful for you. And I realize that this is something that maybe you need to look at in a different way. And I've got a lot of other strategies for how to do these problems, but I didn't want to put them all in one video and make it long. So if this didn't make sense to you, I've got about 3 other ways to do this. Come to me and I'll help you look at it in a different way. But if it does make sense to you, I want you to get that worksheet and I want you to nail these problems. Thanks.